Hi everyone, I'm Mike Poland, the scientist in charge of the Yellowstone Volcano Observatory, and this is the monthly update for April 1st of 2022. Always perhaps a bit tempting to do a practical joke or something on the April 1st update, but I think this update, let's talk about earthquakes. Because we had a little seismic swarm at Yellowstone during the last week of March. Now, seismic swarms are nothing new in Yellowstone. We typically have dozens of swarms every year, and about 50% of all the earthquakes in Yellowstone are parts of swarms, and there's typically around 2,000 earthquakes or so on average every year. This particular swarm happened in the northwest part of the park. You can see West Yellowstone there, Norris Geyser Basin is here, Yellowstone Lake down in there. Now this swarm started on the evening of Monday, March 28th, and in the first 24 hours, over 100 earthquakes were located as part of the sequence. All of this location work is done by the seismologists at the University of Utah seismograph stations. They maintain all the equipment out there and do all of the earthquake location work. This particular area is a real hotbed for seismicity. In fact, this area in here is the most seismically active part of Yellowstone National Park. Back in 2017, there was a 3-month-long swarm that had over 2,400 located earthquakes in the region. If we look at the last few decades of seismicity in the Yellowstone area, you can see this area of seismicity right here. There's West Yellowstone down there, sort of trending east-west from outside the park just into the Norris area. That's where we see a tremendous number of earthquakes. Blue ones in this map are seismic swarm events, and red ones are discrete earthquakes. Now there's at least 3 reasons that there are so many earthquakes in this region. The first is that there are faults all over the place already. Now Yellowstone sits right on the eastern edge of what we call the Basin and Range extensional province. That stretches from the Tetons in the east to the Sierra Nevada in the west, and from central Idaho and central Montana in the north down to Mexico in the south. And this area is being stretched apart. So there's faults everywhere, and that's what gives you that very characteristic valley, mountain range sort of topography in the region. So there's faults all over the place anyway, and this region is no exception. The second reason, there's a lot of water. Yellowstone sits at the highest elevation on average in the Rockies, so there's a lot of snow, a lot of rain, and when that water starts interacting with those faults, you can get lots and lots of small earthquakes. And in fact, it's even aided a bit more by some of that water being hot. Going down towards the cooling magma body and then recirculating back towards the surface, you get a lot of hot water. So water and fault interactions, that means lots of small earthquakes. The third reason is over 60 years old. And that's this big event that happened just west of the park in 1959, the magnitude 7.3 Hebgen Lake earthquake. This is still the largest earthquake ever recorded in the Intermountain West Region of the United States. It caused a tremendous amount of damage in this area. In fact, a landslide swept into the Madison River Canyon, into a campground, and over 24 people were killed during that event. Big earthquakes like this alter the stress field in the rock that's around where the earthquake happens, and it can make small earthquakes more likely. It created that sort of situation trending into Yellowstone National Park. And so that means small perturbations can now cause small earthquakes. So it's sort of a perfect recipe for earthquakes in this particular area of Yellowstone. You've got a lot of pre-existing faults, a lot of water moving around in the subsurface, and then the stress state of the area, because of that 1959 earthquake, predisposes the area to lots of small earthquakes. So these kinds of earthquake storms are extremely common, especially in this area here. They don't really have anything to do with volcanic activity or magmatic activity. The magma body, the cooling area, mostly solid anyway, is to the south of this area here. So this is really just pre-existing faults, water, and that stress that's left over from the 1959 Hebgen Lake earthquake. All right, now let's talk more detail about what happened during the month of March in terms of seismicity, in terms of deformation, and in terms of geyser activity.
During the month of March, the University of Utah seismograph stations, which is responsible for the operation and maintenance of the Yellowstone seismic network, located 254 earthquakes in the Yellowstone region. And this is pretty typical activity for a given month in Yellowstone. The largest event of the month was a magnitude 2.9 that occurred on March 15th, just north of Yellowstone Lake. There were also 2 swarms that occurred during the month. During the first week of March, there was a swarm of 38 events that were located south of Yellowstone Lake near Heart Lake. And the largest event of this swarm was a magnitude 2.2. And then, of course, there's the swarm we were just talking about in the northwest part of the park. About 115 events have been located in the last week of March, the largest being a magnitude 2.6. So, all in all, a pretty average month for earthquakes in Yellowstone. Deformation trends have remained pretty steady as well over the past few years. This is vertical deformation at the White Lake GPS station, which is on the east side of the caldera on the Sour Creek Resurgent Dome. Each one of these blue dots is 1 day worth of data, and the entire plot spans the past 2 years. Upward trends indicate uplift, and downward trends indicate subsidence. The overall trend during this 2-year period, and in fact stretching all the way back to 2015, is one of overall subsidence, and it's occurring at a rate of about 2 to 3 centimeters or about 1 inch per year. During the summertime, there are these pauses in subsidence or even slight uplift trends. And this is caused by groundwater from snowmelt that percolates into the subsurface, and the ground sort of soaks it up like a sponge. So we see a pause in the subsidence or possibly even a little bit of uplift. But during the winter months, when that snowmelt isn't occurring, we see pretty steady subsidence, as we've seen here from late 2021 into the beginning of 2022. If we go over to the other side of the caldera in the Mallard Lake Resurgent Dome, this is near Old Faithful, the same sort of trend shows up. There's an overall subsidence of a couple of centimeters per year, about 1 inch per year, interrupted during the summer months by a pause in the subsidence, even a slight amount of uplift. The data are kind of noisy during this first part in 2020 due to a lot of trees in the area, but some of those trees were removed in September of 2020 to reduce the fire load in the area as a wildfire approached. There's also a bit of an offset right here. That's caused by a storm that dropped quite a lot of snow in the area and obscured the GPS signal. But otherwise, we see the same sorts of trends in the caldera that we've seen since 2015, that of gradual subsidence of about 2 to 3 centimeters or 1 inch per year. Now, looking at the area of the Norris Geyser Basin, there really hasn't been much of a change at all in the last 2 years. You can see that the deformation shows quite a steady trend. There's a bit of uplift here, apparent uplift in the summer months again in 2021, and that's again due to this groundwater recharge from snow melt percolating into the subsurface. And then this big deviation in December. That's that same storm that affected the GPS station near Old Faithful. It also impacted the station near Norris Geyser Basin. Otherwise, we really haven't seen much in the way of deformation in the Norris area. Finally, moving to everyone's favorite geyser, Steamboat Geyser, tallest active geyser in the world. This is the temperature record in the Steamboat outflow channel. It gets kind of noisy as minor eruptions occur, and then the major eruption occurs, this one on March 4th. After that, we see the same regular sort of diurnal daily variations in temperature, no minor eruptions. Then minor eruptions start picking up again. That's a sign that we're moving towards a major eruption. And again, a major eruption did occur on March 30th, and now we're back to those normal temperature variations as the minor activity has not yet resumed. So Steamboat continues to be active, 2 eruptions during the month of March. Hopefully this means it'll continue putting on a show for us during the summer of 2022.
Well, that does it for the April 1st, 2022 update. Now remember, if you have any questions at all, feel free to email us anytime. Our email address is yvowebteam, that's all one word, @usgs.gov. Have a happy April Fool's Day, stay safe, stay healthy, and we'll see you next month. Bye-bye.